Let's talk about factoring general trinomials by unfalling. When we factor, our steps for factoring are first to take out a greatest common factor. Next, we count the number of terms. When there are three, we say, boy, I hope it's a perfect square trinomial because those are easy. But in this video, we're going to look at the harder problems, general trinomials. In particular, we're going to think about general trinomials that have a positive at the back with a leading coefficient of 1. To help us get going, it'll be useful for us to remember what happened when we multiplied two binomials together, like x plus 2 times x plus 3. Notice that the binomials I've chosen both have the same sign in the middle. They are both positives. When we multiply these, x times x, the first ones, give us x squared. Next, we do the outside things. X times 3, that made 3x. Then the inside things. 2 times x makes 2x. And finally, the last ones, 2 times 3, gives us 6. Since these signs are the same as each other, positive 2 times positive 3, we get a positive back at the back. Now, notice also we've got terms in the middle that can be combined here. They both have the same sign because the things in the parentheses had the same signs as each other. When we add these together, that gives us a result of 5x. Notice the sign of the 5x is the same as the sign that was in the original problem in each set of parentheses. So if we have a positive in the middle of both of those binomials, it'll give us a positive at the back. When those signs are both positive, we get a positive in the middle. What about if we had something that had two negatives, like x minus 2 and x minus 3? X times x, the first one's made x squared. On the outside, x times negative 3 made negative 3x. On the inside, negative 2 times x made negative 2x. And then the last, negative 2 times negative 3, made a positive 6. Two negatives multiply to be a positive 6. So again, back at the back, since the signs are the same as each other in the parentheses, we're getting a positive at the back. Whatever that sign is, that's the sign that we get in the middle when we add these things together. They both have the same sign, so we're going to keep that sign and add them up to make the minus 5x that's in the middle. If you've got a positive at the back, it either came from multiplying two negatives together or it came from multiplying two positives together. So when we go to factor things, if we see a positive at the back, that's going to tell me that the signs in the parentheses are the same as each other. Maybe they're two negatives or maybe they're two positives. We can decide which we want by looking in the middle. If we have a negative in the middle, it came from having two negatives in the problem. If we have a positive in the middle, it came from having two positives in the problem. Let's look at one that we actually factor, x squared plus 7x plus 12. Now, I know that I can't take anything common out of this. There are three terms, but it's not a perfect square trinomial because that 7 is odd and the 12, it's not a square. So this tells me I'll need to factor by unfalling. Let's start by putting down two sets of parentheses. How can you make an x squared? You'll take the first thing here and the first thing there to multiply to make this x squared. And the only way I can do that is to say x times x. Now we've noticed on this one that we have a positive sign. That tells me that in these parentheses, whatever the signs are, they're both going to be the same. It's either two positives or it's two negatives. I can decide based on the sign that's in the middle of the problem. Since this is a positive, looks like we need positives in each set of parentheses. Now, I've still got to figure out what things will go back here on the back of each set of parentheses that they can multiply together to make 12. Think of things that multiply to make a 12. It could be 12 and 1. It could be 6 and 2. It could be 4 and 3. Notice that I have systematically listed those things. Something in 1, something in 2, something in 3. Here's 4. When I do it systematically like that, it tells me that I've got all of the possibilities figured out, and I know I haven't missed anybody. So these are the things that will multiply to make a 12 at the back. But now, not only do they need to multiply to make the 12 at the back, they also have to add up to be the 7 that's in the middle. Since our signs are the same, they are adding to be this 7. So let's look at our numbers and think what they add to. 12 and 1 add to 13. That's not it. 6 and 2 add to 8. That's not it. 4 and 3, they add up to 7. So those are the ones that we want. Since the signs are the same, the order that we put these factors in makes no difference. I always like to have the larger thing in front and the smaller thing in back when it makes no difference, but it really doesn't make a difference. So our factored form then is x plus 4 times x plus 3. I can quickly check to see if I've got it right. I don't have to do all of the foiling to make sure. I know x times x, the first ones, made x squared. That's why we chose them. I know 4 times 3, the last ones, make 12. That's why we chose all of these things. So all I've got to do is to check that the outside things, x times 3, 3x, and the inside things, 4 times x, 4x, add up to what we want in the middle. 3x and 4x made 7x, so it worked. Let's look at another one. Here, x squared minus 11x plus 24. Again, it's not a perfect square trinomial. There's nothing common. I've got an odd in the middle, so it can't be a perfect square trinomial. Let's get two sets of parentheses, binomial times binomial, for us to try to factor this. Again, to make the x squared on the front, let's do x times x. Our signs are the same. This time, they're both going to be negatives, so we can go ahead and put two negatives in. Things that will multiply to be a 24, systematically listing them: 24 and 1, 12 and 2, 8 and 3, 6 and 4, and I see that 5 won't go into it, so this is my list of the factors of 24. We need things that add up to be negative 11. They're going to be adding because, remember, both things have negative signs. 24 and 1 add to be 25. That's not it. 12 and 2 add to be 14. That's not it. 8 times 3, they add up to 11. 8 times 3 made 24, and 8 plus 3 adds up to 11. So those are the factors that we want. Again, the order makes no difference. I like the larger one to be in the front and the smaller one to be in the back, but it made no difference the order that we put it in. Now, again, let's check and be sure that we're right. No need to do all of the foiling. I know x times x is x squared. I know on the back, negative 8 times negative 3 made 24. That's why we picked these factors. All I've got to check is, do I have on the outside minus 3x, the inside minus 8x? Do those things add up to be the minus 11 that we wanted in the middle? Minus 3x minus 8x, they add up to minus 11x, and so we've got it right. When you are factoring, look for something common to take out first. Count the number of terms. If there are 3 terms, say, boy, I hope it's a perfect square trinomial, but if it is not, then we factor by unfoiling. If there is a positive sign at the back, the signs in the parentheses are the same as each other, either 2 positives or 2 negatives. We can decide which we want based on the middle sign. If the sign's negative, then we'll need 2 negatives. If the sign's positive, then we'll need 2 positives. We have to think of things that multiply to be the number at the back and also add up to be the number in the middle. When the signs are the same, we are adding to get what is in the middle.